Hello world, my name is Josh and today I'm going to teach you how to make self-learning games using reinforcement learning. In this tutorial, I not only touch upon the topic of reinforcement learning, but also give you a bit by bit explanation of the code for a particular game. The prerequisites for this tutorial are basic understanding of object-oriented programming with Python. Before we dive into the code, it is really essential to understand the technique we will use. So what is reinforcement learning? Reinforcement learning is a branch of machine learning which is different from supervised and unsupervised learning, as it requires no dataset for training. Reinforcement learning comprises of two constant components and three components that keep changing with every time step. The constant components are agent, the thing that takes an active role by implementing different actions. The second component is environment, some model of the world which is external to the agent. It provides the agent with the observation based on which the agent takes action and gets a reward for its action. The environment changes the state of the agent based on the action taken by the agent. Our agent's goal is to find a set of actions that would maximize its overall reward. For this tutorial, we will use OpenAI's Gem as it will provide us with our environment. This will not only save us time, but also make our work so much easier. Gem not only has environments for multiple games, but also consists of various robotics and physics problem environments. Do check out their site, I'll put a link in the description below. We choose Mrs. Pac-Man as the self-learning game for the tutorial. We are not ready to start coding just yet. Make sure to download the following packages if you don't have them. The required packages are Gem, Atari, TensorFlow, Matplotlib, Collections, Random, and NumPy. You can install the packages by typing pip install followed by the package name in your terminal. Now we are ready to get our hands dirty with some coding. Open the text editor of your choice and import the following packages. Gem helps us create an environment and its functions. Matplotlib plots the performance of our agent over time. Collections store the observation from the environment. And finally, all the TensorFlow packages helps us design our neural networks. After importing all the packages, we define some global variables. Episodes is the number of games our agent plays to train itself. Load model variable decides whether we are training or testing our agent. When load model is false, it indicates that our agent is training instead of testing. When the agent is training instead of testing, the neural networks save the weights after every 50 games. Apart from that, the only significant difference between training and testing are the hyperparameters of our agent class. Now we initialize our agent class. Let's try to understand the intuition behind some of the essential hyperparameters. State size is provided by the environment and is the size of the state. In the case of Mrs. Pac-Man, it is the value of 128. Action size is the number of actions an agent can take. It can be continuous. However, in our case, it is the discrete value of 9. Epsilon. This value ranges between 0 and 1. Closer the value is to 0, more our agent exploits. That is used in testing. Closer the value is to 1, more our agent is gonna explore. And this strategy is used mostly in training. After initialization, it's time to give our agent a brain. We use DQ data type as agent's memory and store it in a variable called memory. This is followed by making a variable called model, which stores the neural network that we built to decide what action to take. Moving on, we give our agent some functionalities. The first function is the build model function. The function itself takes no input or produces no output. However, it creates a neural network. The input of the neural network is the state the agent is in. The output of the network is an approximation of all the rewards our agent can end up with. Think of the output as a table, where the first column is the list of actions, the second column is the approximate reward our agent gets at the end of the game for the corresponding actions. The second function is called getAction function, which takes the state of the agent as its input. After using the neural networks, it returns the action, which has the approximation of highest possible reward. As you may remember, we had defined a variable called memory. The append sample function takes the state of the agent, action the agent took, reward the agent received for that action, the next state based on the agent's action, and if the game is done or not as its inputs. After which, it stores all the information in the memory of the agent. This function does not return any output. The final function of the agent class is called the train model function. You could call this function the heavy lifter, even though it does not have any input or output. In this function, we take a random sample of the memory and train the neural network we created. The size of the random sample can be changed by increasing or decreasing the value of batch size in the hyperparameters. We have finally finished coding our agent class. It's high time we put our agent into the real world and let it teach itself. We first make an instance of the environment and save it in the variable called env, after which we get the state size and the action size from the environment. We use the two variables to create an instance of the agent using the agent class, saving it in a variable called agent. Now that we have put the agent inside the world, it is time to let the agent train itself over X number of games, where X is the number of episodes. Every iteration in this for loop signifies one game our agent plays. In one game, our agent gets 3 lives to maximize its score. Inside the for loop, there is a while loop that goes on while the agent is not done. That is, 3 lives are not over. The while loop is the main crux of our computation for the agent. In this loop, our agent takes action based on the state it is in, gets a reward for its action, and changes its state based on the action. Not only does this information get sent to the memory, but also based on this information, the neural networks updates itself. Every time our agent dies, it gets a negative reward of 100. Once our agent dies 3 times, the final score for the game and the game number gets stored in a list that we initialized outside our for loop. This information gets plotted and we print some statistics about the particular game. Once one iteration of the for loop is over, the environment gets reset and the whole process repeats itself. Every 50 games, the weights of the neural networks get saved if we were training the model. That's it for the code, folks. Now we save our script and go to the terminal to run it. First, navigate to the directory you have saved your script in and run it by typing Python followed by the name of the script. I hope you all got a basic understanding of using reinforcement learning to play arcade games. Feel free to experiment with the code to improve its performance or apply this to some other game available in Gym. I'll put a link to the GitHub repository and the blog post for this tutorial below. Don't forget to like, subscribe, and share. Feel free to drop in questions for this tutorial and suggestions on what topic I should cover in my next tutorial. See you all soon. Till then, happy coding.